You ready?
Yes, I'm ready. Okay, this segment is the third segment, which now we learn the knocks, we learn the vanes. This segment is about how do we put all together with the rest of the components. Believe it or not, Aerovane jig is not a simple jig, as you can imagine. It got quite a lot of very important features. Aerovane jig have, first of all, 7+1 different chucks. Most people are not familiar with them also. I put them actually on our catalog. If you look at our catalog on page, just wanted to show you, didn't say the wrong number, page 7, the tiny picture in the middle, which is this picture right here in front of you. Let me go through them so at least you got to know what they look like. That's called the adjustable chuck. One next to it is called adjustable hook. The reason they're adjustable because they can fit every single size. The beauty of an adjustable hook is that it doesn't grab the inside, it actually grabs the outside. If you have not seen an adjustable hook, this is what it looks like. So instead of letting the shaft go into it, the adjustable hook, a chuck, will let you grab the arrow from the outside in.
Why does a rod have that?
Because this is, it's just like, if you are a top mechanic, would you want a crescent wrench or a box of snap-on? You want a box of snap-on because you want perfect size.
Yeah.
This is a crescent wrench. It'll give you all the sizes, but not perfect. Rod won't accept anything that's not perfect.
Exactly. I know.
And that's exactly why he didn't have this. But for the person who, as a shop, when you set up a jig, and a customer comes to you with 3 arrows with 1 vane off, do you want to swap chucks?
No.
Since you only put 1 vane on, this becomes the most beneficial equipment.
Fast.
You just put it on, using a laser, align it, put the vane on. You're doing 1 vane. That's where the adjustable chuck and adjustable hook shines. Because it lets you adjust the height of the hook. See that height of these 3 hooks are different. These 2 are the same, these 2 are the same, these 2 are the same.
Yeah.
By doing so, we're now able to tie these 2 together. That's where the difference is. Did you give me my power for the...
Oh, I'm not using it.
Good, so let me go.
Yeah, it's unplugged.
Thank you. If it's going to be on, eventually it will shut off. I know you'll go to sleep. Because this is powering the monitor.
Yeah.
Good. You can see that the height of these 3 hooks are quite different. The gold hook are closer compared to the black hook compared to the gold hook.
Yep.
See that? These 2 points are closer and further.
Yeah.
Now the only way to overcome it using this piece is that this wing move up and down. Like where I'm showing you now. Take a closer look.
Yeah.
So instead of pre-adjusting what you have, you can use this to cover everyone.
Yep.
So with this one, you can pre-adjust or you can cover everyone. So this becomes your absolute perfect single flush repair kit system. But when you do production, a single chuck is the best because do you have to afraid that it will open? It is only one size. Which is your 166 chuck, your pin knock, your 235, or your 202, which is your exercise. Then the next one is your H size, which is your AC injection micro Waddell, your hex, your Epic. Huh? No, Black Eagle do not have anything the H size. The Black Eagle is the Rampage, is this, the 202. Then you go to the next one, the 235 size, and then the 244 size, this is your standard. This handle 240 to 250. And finally your Carbon Express crossbow bolt and your regular crossbow bolt. So what happens when you start dealing with, say, the Black Eagle Magnums, Challengers, and so on? Then you have to use either a pin knock, an A knock, an S knock,
What about the
or the adjustable one.
What about the SM packs?
The S impact, X impacts, they are all 166 GNAC size.
All of them are.
The
Same as the
GNAC,
deep. Same as the deep. Same
Yes.
arrow, but different.
they are all 165. The difference between the X impact and the deep impact is the material.
It is?
Yes. The material of the X impact is still based on 33-ton carbon, and the S impact is based, the deep impact is based on the 24-ton carbon.
So which one's better?
It is like asking, is a Ford truck better or the sports car is better?
Sport.
What are you doing with it?
That's true.
It's like asking you, a hamburger better or a steak is better? You're driving.
Yeah,
You only have one choice. You can't eat the steak when you're driving.
it's true.
Or if you want a whole 10 piece of 2x4, what good is a sports car?
Yeah.
But you want to go there, pick up a girl, now we may need a decent looking sports car. So that's a wrong question. What do you want it to do?
Yep.
The X impact is not better than the deep impact. The deep impact is a higher grain carbon, which means that you have more weight. It's more durable. The X impact is lighter. It's more brittle. That means it's good for longer range shooting. It can have you a thinner arrow with more spine. So one is for speed, the other is for power. It's like holding a knife and an axe. Which one is better? What do you want to do?
Yep.
That's the same thing. That's the reason when you look at AC injection, it's just like holding a butter knife. You can cut and you know you can cut.
Yeah.
I'm not fond of it, you can imagine. Now this will give you the full chuck system using the same jig.
Yep.
Now in order to make the jig work, we already discussed how important the glue is. And I'm very happy to tell you as of 2012 November, I introduced this tip. Have you ever tried without this tip? You should. Then you will know how important this tip is.
I haven't built any yet, but I think it's going to happen soon.
Yes, I think it will. Okay, now we go into talking about the aero components. It's where before you learn how to build them. Let's make sure we know all the terminology. This is the shaft.
Yep.
That's the knock.
Yep.
In front of the knock, there should be the vanes.
Yep.
On the other end, we should have inserts.
Yep.
Then we have fuel points. If any of the component on this thing is not perfectly balanced, how well would this spin?
Not very good.
Now, for most people, they never really care because they only turn 2 to 3 turns with the first 20 yards. But the moment you start using my stuff, it goes 60, it goes 120. How important do you think this is?
Very.
It becomes critical. That's the reason I'm happy to tell you, for the last 2 years alone, just on aero components, I got 6 + 2 US patents. You start with the point to back. Of course, we know, our Firenock knocks have design patent, utility patent, the whole 9 yards. The vane, no question asked. You already know how good we are in putting the vanes together and how precise they are in balancing.
Yep.
We already know using Aerovane jig how precise we can put it on. And with the right glue, we do that too. So what's left?
Inserts and field points.
Insert and the field points. Now, on a typical field point, on a typical insert, how do you guarantee, assume that you get the insert perfectly in your arrow shaft. How do you guarantee the field point or the broadhead is perfectly centered?
I don't know.
Nobody actually knows.
Yeah.
Everybody, what they do is that when they put a field point on, they will put what you call a broadhead tuner, which very close to what a Firenock APS system can do, which we also got. With the APS system, you notice there's 2 surfaces right here.
Yep.
Rod may not have one of these, but I think he should have.
I'll talk him into it.
You put it right here, put a white piece of paper here,
Yep.
and then you got an arrow with a field point. Do you know why you put a white piece of paper here? Or a sticker? So that when you put this thing right here, when you turn it, guess what happened? If the field point is not perfect or the broadhead is not perfect, you'll make a circle.
Yep.
Then you loosen the field point and you tighten it again. You loosen the field point and you tighten again. And you do it until it's perfect. Only one small problem. What happens when you shoot it? The moment you shoot it, it's moved.
Yeah.
It's no longer perfect again. That's the battle that everybody with archery is fighting. How do we your computer just shut off.
I think I pushed record, didn't I?
No, your call is fully, you have enough memory?
Yeah. It's still recording.
Then how do we shut off? It's okay. Didn't want you to not have your.
Yeah.
So, how can we overcome it? I was fighting with this because I was building aeroboats. The aeroboats was designed to fly over 550 feet per second. Of course, then you start shooting with 435 feet, 415 feet per second. It becomes obvious something needs to be addressed with
Yeah.
the fuel point. Look at that picture in front of you. That is actually an arrow point. I'm going to put one in your hand. I'll let you screw into an arrow shaft until you tell me what just happened. Then I will explain that in technical terms. First, you push it into the shaft first.
These are light.
I know, those are CR5 titanium points. Push it in first and then slightly rotate it. Okay. You notice that all of a sudden you feel like the fuel point is being snugged.
Yeah.
And keep going until you feel the very, very end. Do you think it's moving anywhere?
Mm-hmm.
The whole idea, this whole concept is called a FAT technology, also called an arrow point system. See these two O-rings?
Yeah.
This O-ring is 0.5,000 taller than this O-ring by machine. This two O-ring is the same size. So when you first put a pipe in it, the pipe is aligned by the O-ring. As a pipe is aligned by two O-ring, what's guaranteed? Assuming this is one pipe and the outer side is a secondary pipe, they are perfectly guaranteed to be concentric. That's exactly what a pipe filter do. And that's exactly the reason there's two O-rings. You automatic concentric the fuel point to the insert.
Why do you make a broadhead like that?
I did. I actually licensed the technology to two companies and there are a few more coming up, all using this technology. The first company who actually licensed this is Ramcat from Smoke.
Yeah.
The second company who have that is Hardcraft with the trophy, Hardcraft Exchange Systems. And there are a few more all coming in. Because this will eliminate all broadhead alignment issue. But it cannot help company who make broadhead that's not centered.
Ridge?
I would prefer not say anything.
Not centered.
Mm-hmm.
So you're not making it expandable?
I don't,
Not yet.
not yet. That is other company with expandable discussing with me.
What is the cutting diameter? What's the cutting diameter?
First of all, who care what the cutting diameter if you hit exactly what you aim at?
Exactly.
My belief is that no broadhead should ever be more than 1 1/16 inch wide.
You don't need it to be if you hit where you want to.
Exactly. What do you think what the Aerovane, the concentric shaft is doing? So how much do you need to cut if you aim at the upper left ventricle of an animal?
Not
And you cut that exactly.
Not very much. And ½ inch.
Exactly. And you have 1 1/16 is already excessive.
Yeah.
Now that is where the Aerovane technology is. Now take a closer look at this system. This is very different from everything else. You notice how much shape difference that is?
Mm-hmm.
This is a 45 grain stainless steel point. That's a 9 millimeter 100 grain, and this is a 100 grain 8 millimeter, and you're holding a 45 grain titanium. We'll bring you to further system as we discuss.
Yeah.
Now, if we can control the fuel point, what's the next thing we have to control?
Inserts.
The insert. How do you guarantee the insert is indeed perfect centered in the shaft? Like this. The moment you got a shaft, you got an insert, you got glue. What's preventing this insert to be like this?
Nothing.
So how would it not be like that every time you glue it? Because when you glue the insert, you lay it on the table. The gravity gonna pull the insert down. So what happened to the insert? It is not concentric. But everybody just glue the insert in and it's called it centered. And actually it get a lot worse when you start doing outserts. Because now it's obvious.
Yeah.
Because you can see them now. People say inserts are so much better. No. Inserts are so much better because you can't see the problem you have, not that they are better.
Yeah.
Just because you can't see them, do not mean they don't exist. So what did I do? I actually got another patent on this. It's called a Firenock Insert A technology. You see the two inserts?
Yep.
And this one, these two are the same size, but they are for the Rampage. This is for the 204, 204, and 245, 246, 244. That is a unique capability of this insert. This is the uniqueness of it. Let me grab a nap. The uniqueness of this insert is where make everything changes. I'm going to show you now. This is a typical insert. And the shafts go here.
Yep.
And you can see that that's where the problem is.
Mm-hmm.
Okay, how can I guarantee this one and this one is centered? If I machine this perfectly.
Your jig.
No, my jigs won't be able to do that. Look at what I'm going to do.
Give it a lip so it sits there.
I'm going to machine the lip, a 45-degree lip right here. What I mean when I machine this 45-degree lip and the shaft push in, this is going to behave like a funnel, isn't it?
Yep.
And this is going to behave like
Something pouring
into the funnel. What do you think this 245-degree is going to do with this shaft?
equal it out center.
Exactly. So if you use slow set epoxy, you start shooting this thing. A few shots, you'll crumble the outer side of the carbon. You'll crumble, crumble, crumble. And you will reach this point. You'll crumble, 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 reach this point. How centered do you think this insert is going to be?
Centered.
Absolutely. The more you shoot it, the more center you get. A lot of people have objection to this method because they say, well, if I use super glue, the moment you shoot it, you're going to crumble this. I say, absolutely. The only way to make it, if you want to super glue, is to chamfer the shaft first before you put it in. Or else you use slow set 2-part epoxy, which has flexibility, which allow you to slowly sink your shaft into it. This is only 3/1000ths. They will be able to handle it. So let me give you a closer look at what the insert looks like. And then give you one of my shafts. So you can appreciate how excited it can get. Put the insert out so you can appreciate the 45-degree underneath here.
Yeah.
Now push the shaft together. It is not just protected. It will now curl the shaft into the center. So the moment you put it together, how concentric are they?
Perfect.
What a perfect word. Now if your insert is perfect, your field point is perfect, your shaft is spined, your vein is balanced, the knot is concentric, how bad do you think the arrow can fly?
It can.
It's all in the shooter now. Because the equipment have no more flaw in it. But isn't it funny that all this year, nobody ever had anything to address that?
Yeah. Now why is this tapered?
Hmm?
Why is this tapered? Why is it bigger at the end of the shaft than it is back here?
Because this is a 204 shaft.
Okay.
What does that mean?
I have no idea.
The 204 shaft is a smaller head. And by making it a bigger head, see that? See, by making a bigger head, I have more material here. Just like every single design, the moment you puncture something with a bigger hole, and they're smaller, what happened to it?
Less drag.
Yes. And since all field points minimum current size are 5/16, which is all 8mm, it won't really make sense to make it exactly 8mm, so I don't have to make something like a 7.5, 7.0, and so on. And by making it so, it will actually puncture even better.
So it's acting as an insert in and outsert at the same time.
Correct. That's the reason it's called a Firenock Insert A220 series.
Huh.
It's called a half out. But we also make the Firenock Insert, actually a true insert for the size like the Black Eagle, the Gold Tip, and so on. But that insert also a very interesting part. Take one out and see and take a closer look. The insert is actually also got 2 US patents on it. See, the first one is on the very back side. You see the round part right here?
Yep.
Guess what it behaves like? A ball joint. The very end.
Yeah.
What happens when you put an arrow who behave like a ball joint in a shaft? You maintain the back axis. And what happens in it is reverse tapered. When you push this thing into the shaft, which you can, what do you think is going to behave? Just push it down all the way. And then just push it down. Boom. How center do you think it's going to be?
Perfect.
What a perfect word. How many inserts that you have done look like that?
None.
Okay. That's the whole idea. We want to address that things that nobody ever addressed. Now, how good do you think that shaft is going to shoot when you put a field point on it?
Perfect.
Because everything's concentric.
Does Rod use these?
No, Rod's using outer systems because
Wow.
it's injection and AC injection.
He's using both. We build both. So he needs to be using this.
Now, the first one called the outer system, they are to address the 166 ID. This is address the 204 ID, which is the rampage side, which is called the medium, the slim shaft. This one is called the standard shaft. You can see on the standard shaft that's quite different on the design.
Yep.
And you notice that there is absolutely no weight to that thing.
Yeah.
But just like everything I design, you can always add weight, but how do you take weight out? That's the reason at the back of every single my insert, the thread is all the way through. If it's all the way through, what does that mean? You can always add weight.
Yes.
But if you want to be lightweight, how do you take weight out? You couldn't. So I already put mine all the way to the bottom already. Okay, as you increase arrow size, larger and larger and larger size, all this design become non-effective. That's where we bring to our next subject, the ferro insert D, as in double shoulder insert. This is one of the most innovative systems from Firenock, and 99% of every single dealer never understand this. If your shaft become big, your insert become bigger because the inside shaft is small. Your error of making this straight to the shaft goes sky high. How do you make sure this is straight? The only other method is to make this insert longer.
Yes.
If this insert is longer, what does that do? You get heavier, which means they're less effective on a bigger shaft. This is 300 size and 315 size shaft, which means they are this size or bigger. How do you get an insert in it that's totally lightweight, perfectly centered, and perfect?
With that one right there.
Exactly. It's called a hybrid insert system. It's actually a double shoulder. You also got a hybrid. See this two shoulder, every single insert only have one shoulder.
Yeah.
One real wild guess why is that there's two different shoulders.
The center.
Center with what? This is the magic. See this shoulder, we already know that basically if this is a 22 size,
Yeah.
this shoulder is a 300 size ID shoulder. So why did we have a secondary shoulder?
To reach it up to the field point.
So we can actually add a piece of carbon to go behind it, to start with, which make this into a hybrid insert. Imagine this. This insert is barely 1 inch long. If I add 5 inch of carbon and stick it behind here and stop here, how long is my insert? 5.5 inch long. When you have 5.5 inch long, what's the chance of it not being straight?
Pretty slim and done.
And what happened to the insert gluing surface? It is just jumped 500%.
Yep.
And not to mention, what does it do to the arrow itself?
Strengthens it.
is significantly strengthen it from the front to the back, which will save that portion for the arrow target concept. But you can imagine what happened to this insert. Usually on an insert like this size, on a bow, on an arrow like this size, they use brass. They use ultralight aluminum that make it 2-inch long to make it strengthen. But if your arrow is 22 inch and you put a 2-inch insert, what does that do to the arrow? The arrow length, effective length, just drop down to 20 inches. A solid 22 with a possible gap of here, because it's such a sharp gap. So it's going to break right here if it happens. But if I put a piece of carbon right here, what does the carbon do? It flexes. The insert with a carbon become a hybrid system. When I put the whole hybrid system into a shaft, you end up with an arrow with technically 3 different spines.
Yeah.
On a Black Eagle 350, this is like 300. This is like 200. This is like 100.
Why couldn't you make one the full length of the shaft?
If you make it full length of the shaft, what's the weight of it?
It's gonna be more, obviously.
And how fast would we? What is the #1 enemy against flight?
Speed.
Weight.
Weight.
When you make it full length, you lose the weight. At the same time, what's the most benefit of a shaft when it flexes? It absorbs and transfers the energy most efficiently. When it's solid, does it transfer energy efficiently? It behaves more like a boat. It is no longer an arrow because it no longer do this. This actually solves all this problem in one shot, which is the Firenock Insert D, which have done the 300 and 315 size. Now before we go into the arrow target concept, I want to finish it with the arrow outsert. This is what most people with the injection size use. Why? Because when you look at a 166 size, the inside core is only 166. And when you look at a field point, and you actually hold the injection size arrow, you'll find out there is nothing physical side will go into the arrow beside a little bit of threaded part. It all was on the outside.
Yep.
So how do you expect this whole thing to be the inside? The answer is you couldn't, because it won't. It's physically impossible. So why do you want to make an insert that cannot hold a standard size into a shaft that won't hold it? So the only thing that makes sense is to make an outsert system. But the outsert system is not an easy system, because the outsert system, if you make it wrong, everything is exaggerated.
Yep.
Like if you do not glue this insert in correctly, guess what? It wobbles. And that's the reason I actually make a video on our website to teach you how to put this in correctly using one of this machine. I'll do a fast one with you so that you know exactly what to do it.
Yeah.
The first time you put it in, first of all you want to make sure the shaft is indeed clean, there's no dirt on it. You clean the outside perfectly first. Then you put the outsert on the shaft. The moment you put on it, you want to now actually move this thing backward so you can see the outsert with the edge right here.
Yep.
It's even easier to put a white piece of paper so you can see how much you moved. And you spin this. If you see the outsert is moving, what do? You hold the outsert, you turn the outsert 180 degrees, and you do it again. And you turn it and you do it again. You turn it and you do it again. Guess what happened? You're using the glue in the outsert to flow just right. The moment you get it right, take it out, you put it straight down. Guess what? You just got it perfectly centered and glued. If you leave it on a table like this, what do you have? It's going to sink and this. And that's what happened to 90% of the guys. Oh, they just put it together, it looks perfect. And they lay it like this. Isn't that simple?
Yeah.
But the moment I explain to you, it makes sense now, isn't it? And if you don't do what I just told you what happened, every one of them will be off. And who do you blame?
Rod.
Because see, if the outsert is a little bit off, you can correct it with this method already. Yes, but you're finished with it. In some outsert, you'll find out that you need to push it down. In the very top, it may not be perfectly balanced because it may be a little bit this way.
Yep.
What can you do at that moment? Using a machine like this. put a 220 grit sandpaper, push it against this. What you just did? You just perfectly square
Yeah,
the insert when you're finished with it.
with sandpaper.
Yeah, just 220 grit sandpaper.
Yep,
So how perfect is this now?
perfect.
Now this is exactly what it looks like inside. This is where the carbon tube is, right?
Yeah,
This piece is where the outsert is.
yeah,
At this very moment, you see all three majors are aligned.
yep,
What's the fulcrum point? Right here. How weak is this system? All three is the weakest part, is where the strongest is.
yeah.
How would it bend?
It
It
won't.
couldn't.
Can't.
And look at that, the field point actually go into the insert. The thread go into the insert and the thread is also accommodated. At this very moment, all three are aligned.
Mm-hmm.
Why would you use anything else besides this if you want a shaft of that size? And that's a question I asked a few people. And the only thing they can think of is that in the traditional way, this outsert will make removing an arrow from animal and target extremely difficult. Because the moment when this thing goes, because it's a larger surface with a small surface, the moment you go to an animal or a bag, you have a wedge effect. Now you can't pull it out.
I've experienced this before.
Now, just like everything else, what you do experience is called a wedge effect. But what happens if I put knife edge on this? You just literally cut it.
Ram cats.
That's the reason. See that all arrow inserts have this. Those are called blood channels. Those are pressure relief. Because see, when an animal come by, this wedge right here, the moment it reach this point is the maximum point.
Just gonna just cut it.
It's going to cut it or relieve pressure.
Yep.
Because see, what's pressure? Pressure is force over area. The moment you diminishing area, what happened? You can't form the force. Because when you reach this point, as it move higher and higher, the surface actually gets smaller and smaller and smaller. It is like a reverse edge. Just like when you sharpen the edge, you have less and less power to cut. And that's exactly why you call the blood channels. Pretty cool, huh?
Yeah.
Now, since we addressed both ends, what happens when you shoot an arrow that's that big and the knot is only this big? You have to find something to cover the both.
Yeah.
Are you familiar with an older shaft called unit bushing? A unit bushing is a piece of aluminum that go between the knot size and the arrow size. In the old days, making a knot mold is extremely expensive. And Eastern make all kind of aluminum shafts. And they discover, since they can't make the knot in every single size, the only way to cover it is make a bushing to go between the knot and the shaft. Because they have to be machined anyway.
Yep.
So everyone had to be made. So they come with a called the unit bushing concept. It expired 2 years ago, the patent. Except one small problem. Using a unit bushing concept in an all-target arrow, we're talking a hunk of aluminum that is never ever perfect with the knock or the shaft, because all shafts are different sizes.
Yep.
And when you manufacture them, there's always a little bit of variance. And you're looking at the Firenock arrow bushing concept. You notice they are actually squared.
Yep.
What I did is that I have decided to put a square peg in a round hole. A normal bushing being round, this is the normal weight on a 315 size, is about 28 to 32 grain. The knot is 12, which push it at 45 to 50 grain. Make a wild guess on how heavy this is.
7.
On the bushing itself plus 5, 12, compared to 38 to 50.
Yeah.
Now push it together and see how perfect it feels. How do you like it?
Yeah. This doesn't make the back of the arrow square now? It's not
No,
stretching the back of the arrow?
it's making it this. Very good question. Does it make the arrow that? As a matter of fact, my entire system is betting on it. 99% of old traditional bushing. How do you feel this space?
Center.
Warm-up back. You put a warm-up back, you push it in and you try to trim it. What if the warm-up back is double right here or double right here? This thing is shifted right here.
Yep.
It's never ever perfect. Am I right?
Yep.
So now, in my concept, we know one thing. For all arrow shaft, the only thing is perfectly round is the mandrel, which is the where the carbon is rolled onto. And if I put a square piece right here, and if this square piece is indeed perfectly machined and round edge, I have pressure here, pressure here, pressure here, and pressure here. How centered is this piece?
Perfect.
Okay. We know that the larger shaft, the carbon is super thin, which means they are flexible. What is centering this piece? The flexible carbon. Is the carbon turning from a perfectly round to a slightly square shape? Absolutely. That's what it is called, a square peg in a round hole. And that's the reason you feel that. That's not because of the friction, it's because of the tension from the carbon on all corner.
Flexing out.
And that's the reason on the bottom of this part, you see how round this is?
Yep.
That is to relieve that initial pressure.
From stopping it from cracking.
Correct. And that's what arrow bushing is. Overall, the arrow bushing will drop from a normal arrow shaft's weight by 70%, which I think is quite significant.
Yeah.
I don't think anybody come close to 70%.
No.
If you take a closer look, we actually got a second pattern on here. See how we drill the hole on both sides?
Yep.
How this is center over center? But the most significant part is actually right in here. In here. What does it look like to you?
A lip.
A lip. Where do we see this? The arrow inserts, isn't it?
Mm-hmm.
The moment I put a thin shaft of this thickness, 0.5 millimeter, which is about the normal size of a target shaft, guess what? Within 3-4 shots, it will go into this. What does it do? It not just center it. When an arrow hit from the back, what does it do? It's a 45-degree relief pressure. It protects the shaft even from back hit.
Huh.
Now how protected is this shaft?
100%.
Isn't that beautiful?
Yeah.
Isn't that funny? Nobody got this yet. Now, this brings us back to where the arrow Firenock target concept is. Remember we talked about the insert?
Yep.
The viewpoint?
Yep.
The shaft?
Yep.
When you put this together, you form this, right?
Yep.
You put this into this, you form this.
Yep.
You put this whole thing into this. Now, the magic is that in the traditional, everybody using a glue-in point like this, that's 100 grain. 45, 18, 38. What do we got? 100 grain. Ta-da! In this.
Huh. And you're straightening at the same time.
No, we actually do a few more things like that. Okay, what does the arrow do when you flex it? When you shoot it, the arrow do this.
Yep.
We will discuss this when we go to arrowing tools. Assume that this arrow, every arrow we have will flex exactly like this.
Yep.
What does it do? You keep on doing this for the first 15 yards, which is the normal norm.
Yeah.
What happens when we put this piece in?
It doesn't do that.
You can't do that easily anymore because the shaft is now shift. It's shift from a total different design. The shaft is no longer an ordinary shaft because it got a secondary piece in it. Which you can see from here. the more I bend it. See how this part goes straight?
Yep.
And then it's curved, and then finally curved. Which means that the moment I shoot this shaft, this part will prevent this part from bending. In the physics term, it's called oscillation, harmonic dampening. Because this shaft is trying to go to its simple harmonic. Okay? This is actually the reverse of this. It's trying to make this part not bend. It's like holding a long string of guitar and you just put a finger right there.
Yep. It's not gonna allow.
This is going to, now all of a sudden the frequency is going to bend backside and this side is dead. But then what is this shaft going to do? This shaft is actually going to do this, which I will try my best to draw it. That's the main shaft. The oscillation frequency will be very close to this compared to this.
Yep.
Because it's actually a little bit closer to this. If this is not oscillating, what happened to the energy? It is not wasting it. What happened to the tail end of the vane that is pointing this way and pointing this way? The chaos become a lot more normal. Which means that the direction of the vane now will be faster controlled for the forward instead of pointing at off-center vectors. Which means that the vane itself, the moment when you flex it, where's the vane pointing at? It's not pointing forward, isn't it?
Nope.
It's pointing at different angles. So the earlier we can correct this to be this, the better off we are.
Further back you put it, the earlier you can
Correct. So with this system, compare the arrow doing this. And look at what this arrow actually does.
Huh.
The arrow with the arrow target concept, it's going to stop flexing about 7 feet and go full gyro.
It's a lot more energy for.
It's about close to 75% more, it's 300% more efficient. Instead of wasting 15 yards, you do it in 7 feet, 7.5 feet. 7 feet to 7.5 feet.
And the amount of energy is.
Stored.
Yeah.
Guess what the energy is going to store into?
Right.
Especially with Aerovane 2 or Aerovane 3. It's now storing in as a rotational mass. Normal arrow, when it hits something, it just hit, penetration equals to the kinetic energy equals to speed plus weight. But not when you shoot Aerovane. It's speed plus weight plus stored rotational energy on impact release. You automatically get 9 to 15%. Isn't that interesting?
Yeah.
So if you shoot 100 KE, you should expect the cutting capabilities about closer to 110.
Yep.
Would you take that 10? Any day.
Yes.
And that's exactly, now with the help of Tim Boykin, one of the ASA Pro, we found out that compared to a normal arrow with a blazer, shooting out his bow at 297, the Aerovane equipped arrow target concept arrow, identical in length. Although launch out a bow at 297, it dropped like a 325. So the launch speed have not changed, but the drop have changed.
Yep.
Which means the arrow have a longer hang time. Which means the normal arrow will fly out like this. But this arrow actually fly out like this. That's the reason you find out it's really weird. When you start shooting Aerovane arrows, the moment you walk towards the target, the arrow are not like this,
No.
like this. You notice that the first thing everybody notices that when you shoot Aerovane at long distance, 90% arrow go like that. Our arrow is going like this.
Creates lift.
Because it's actually doing lift. Like an airplane, when you land perfectly, the airplane don't land like this.
No.
They land like this.
And then, yeah. Huh.
Now you know why the Aerovane is so powerful. Because I'm using everything I have, and this is the exact exaggeration of everything I come up with. Which is also happen to be used in crossbow. Believe it or not, everything I just teach you was actually because of page 15, the Firenock arrow bolts. Those are the only crossbow arrow that yours truly have ever come up with and be confident to tell you got a good crossbow. If you want to shoot 145 to 150 yards, go for it. On an archery projectile. Most people think you're nuts.
I can do it with my bow. I can do it with my bow.
At 25 miles per hour wind?
Probably not. Probably not.
Yes, I know, your bow got my Aerovane on it, that's
Yes,
possible.
it does.
Alright. And that concluded our section 3.
I think it's still recording. I think it just goes to sleep. Yeah, the camera's still on.
Good?